What's going on, everybody? I'm Will Button. This is DevOps for Developers, and in this video, we're going head-to-head, mano-a-mano, which IAC will reign supreme, Terraform or Pulumi. So to do that, we need to make sure it's a fair fight. So we are going to build the same application with both tools and look at the differences between the two of them. We're going to be deploying a Next.js blog to an Amazon S3 bucket, hosting that as a website. And then we're going to use Cloudflare for our DNS. And that also gives us the ability to do Cloudflare page rules and take advantage of Cloudflare's DDoS protection. So in this video, we're going to be building an S3 bucket, some S3 ACLs, an S3 bucket policy, creating some Cloudflare DNS entries, and doing a Cloudflare page rule. So the only way to find out which one reigns supreme is to actually start writing some code. So let's go do that now.
Alrighty then, we are going to start with our Terraform implementation. So I'm going to create a new file here. And because it's Terraform, we're going to give it the name main.tf. And let's crank that font up. That might be a little big. There we go. All right, so we're going to start off with our provider of AWS. And we're going to give it a region variable that is going to be set to var.region or var.aws region. And so right away you can see that that is red because that doesn't exist. So we need to do a couple of things here. We're going to create another file and we're going to call that variables.tf. And inside of here, we will give it our name, AWS region. It's a type equal to string. Description is going to be the AWS region. And then we'll give it a default value of US West 2, which is where I run my stuff. You can actually give it whatever region you actually run in. And that switched from red to blue because it's now a known variable. The other thing I'm going to do here, because we're going to deploy this using Terraform Cloud, is we're going to create a file called terraform.auto.tfvars. And we're going to specify those variables in here as well, but this is going to set it up so that whenever we let the cloud provider deploy it, then it will be able to automatically inject those variables. Now, one more thing we've got to take care of here, we specified this AWS provider, so we want to define our providers so that we get the right one. So we'll create another file called providers.tf. And so it's worth mentioning here, since this is a pretty small application, we could put all of this in our main.tf file. I'm breaking it out into different files just to show you what it's going to look like in a larger application, because once you start having a lot more things that you're letting Terraform manage for you, you're really going to appreciate having things broken out into different files like this. So it's overkill for this, but in the real world, you're going to appreciate this level of abstraction. So we're going to define our required providers of AWS. The source for this one is going to be HashiCorp/AWS. And our version that I want is 4.22.0. And I didn't make this up. I make up some stuff, but this time I'm actually pulling in real data. So if you go to the Terraform registry, you can look at the providers. Here's our AWS provider, and this is where I got the version number right there. We need to specify our next provider, which is going to be Cloudflare, because we're going to let Cloudflare manage our DNS for us, which also means that we need to specify our Cloudflare provider. So we'll go back over to our providers file here, and we'll specify Cloudflare, spelled correctly. And then our source is going to be Cloudflare/Cloudflare. And the version for this one is going to be 3.19.0. And I got that from the same Terraform registry website that I just showed you, so I won't waste your time showing that to you again. But now we can start declaring some resources. So we'll start with our AWS resources. So we're going to specify a resource, and we're going to do an AWS S3 bucket, and I'm just going to call it site. And in there, we will give it a bucket name that is going to be equal to var.siteDomain. So we need to add that over here to our variables file. And our description is going to be the website domain name. So there we go. That looks happy now. So that's going to create our S3 bucket. And then we're going to create another resource. This one is going to be AWS S3 bucket website configuration. And we'll call it site. We need to tell it the bucket that we're referring to, and that's going to be our AWS 3 bucket.site.id. And we need to specify a couple other things here, like our index document, because this is going to be our static site. So AWS wants to know what your indexed bucket is. So we'll give it the suffix of index.html. Alrighty then, moving along, we need our next resource. This time we want an AWS S3 bucket ACL. And that again belongs to our site. The bucket that it belongs to is our AWS S3 bucket.site, and we'll use the ID so that we're talking to the same bucket. And our ACL is going to be public read, because we want our website to be publicly accessible to the rest of the world, so it needs that ACL. Our next resource is going to be an AWS S3 bucket policy, again belonging to our site. The bucket is going to be our AWS S3 bucket.site.id. Our policy is going to be JSON encode this stuff. And so now this part should look really, really familiar if you're familiar with IAM or S3 bucket policies. It's a standard bucket policy. We just wrote it out here, and then we're going to tell Terraform to JSON encode it whenever it builds that out. So that's it for our AWS resources. Let's recap that. We created a bucket. We set the configuration of that bucket as a website, gave it our index and error documents, set our ACL to public read, and then gave it our bucket policy that allows everyone to access or get the contents of that bucket. Let's move on to our Cloudflare resources. Again, we're using Cloudflare for our DNS. Now we could use Route 53 for this. The reason I chose Cloudflare is twofold. One, to show you that when you're using Terraform or Pulumi, as you'll see in a couple minutes, that you're not limited to just a single provider. You can use multiple providers. And also with Cloudflare DNS, the way we're going to set this up is we get to take advantage of Cloudflare's DDoS protection that you're really going to want. So we're going to create a data object here called Cloudflare zones with the name of domain. And we're going to filter that to the name of our site, which we specified as a variable. So now we'll define our resources. We're going to do a Cloudflare record, and this is for our site CNAME. So the name is going to be our site domain. The type, oops, screwed that up. It's going to be CNAME. Our zone ID, this is where our data object comes in. Cloudflare zones.domain.zones 0.id. Basically what that says is here in our data block, we're going to grab from our Cloudflare zones the domains and filter it down to the domains that match the name of our website. That returns as an array, which is why we specify 0, the first element of the array here, because there's absolutely no way we can have anything other than one matching record for this domain name. We're creating CNAME, so it's got to have a value. That value is going to be our AWS S3 bucket website configuration.website endpoint. And what that is whenever we configure this bucket in AWS as a website, AWS is going to create their own website or DNS name for that, which is what we're going to point to for our website. TTL, we're just going to give it a value of 1. And then proxied, we're going to set to true here. Now what that does, that's what enables the Cloudflare DDoS protection, and it also allows us to do Cloudflare page rules, which they're not really important for this specific application, but I'm going to show you how they work anyway, just to show you what the workflow looks like on a pull request versus an initial commit. So we'll come back to that. But before we do, we need to create another Cloudflare record for www. Our type's going to be a CNAME again. The zone ID, again, going back to our data, Cloudflare zones.domain.zones0.id. And then the value of this is going to be our root domain. TTL, we're going to set to 1. And then again, we want to proxy this. So we're going to set that to true. And I pushed the files up to my GitHub repo here while you weren't looking. So let's jump over to our Terraform application here. I'm using Terraform Cloud. I don't know if I mentioned this or not. For a couple reasons. One, we're going to use the Pulumi cloud, and so I wanted to use the Terraform cloud as well, so we get an apples to apples comparison. The other reason is managing Terraform state is a pain in the ass, but if I use Terraform cloud, it's not my pain in the ass. So that's the way we're going to do it. We've got a brand new repo, so we're going to start by creating a new workspace as soon as I crank this up for you a little bit. There we go. So we'll do a new workspace, and we're going to use version control. So I'll click there, choose GitHub, and you can use other version control providers if you are using GitLab or whatever. I'm going to choose my repo. This one is called Terraform S3 site. I don't really care about the description. We'll create the workspace, and let's just start a new plan. Let's just go for it, right? You can see right here the little orange button that says planned, and it's going to show me everything that it's going to do based on our configuration. It's going to create the AWS bucket, the web configuration, the bucket policy, the ACL, our Cloudflare CNAMEs, blah, blah, blah. All that's going to be there. And then we need to click confirm and apply. That's going to turn this from a Terraform plan to a Terraform execution. And so now that's all queued up and ready to run. And we get the green check mark and apply finished. So theoretically, we should have some AWS assets to look at. Let's go over here to our buckets. Make the font big and chunky for you. Get rid of that. And if we scroll down through here, check it out. We have a bucket called opswad.io. And if we take a look at the properties, go all the way to the bottom here, static web hosting is enabled. There is our endpoint URL. And so now let's go over to Cloudflare, and we've got our two CNAME records, our www CNAME record that points to opswad.io, and then that root CNAME that points over to our S3 bucket in AWS. So theoretically, if we had some files in here, they would actually be displayed. So let's actually push some files up there. I've got the website that we're going to deploy. It's called Next.js demo, and I've actually already got it set to deploy through GitHub Actions, which looks like it's failing. Let's rerun it anyways. I think it'll work. And that build completed successfully. So let's go back to our S3 bucket, refresh the page here, and there is our website deployed or pushed up to our S3 bucket. So in theory, if I go to opswad.io, there's our website. Let's look at the pull request workflow. One thing I want to do is in my Terraform workspace here, I want to go into settings, version control, and then scroll on down here to the pull request section and turn on automatic speculative plans. And I'll show you exactly what that means here in just a minute. All right, so we're going to create a new branch here because that's how we do it whenever we're making changes. And we're going to call this redirect to will button. You'll see why that makes sense here in a minute. We're going to create a new resource, and we're going to call this a Cloudflare page rule. Redirect to will be our name for it. Our target is going to be the site domain /will. So what that means is if someone goes to opswad.io /will, then we want to send them over to my website. Our zone ID is the data Cloudflare zones domain, zones 0.id. And then for actions, we're going to have a forwarding URL. Status code, this is the HTTP redirect code we want to use. We want to use a 302. And the URL is going to be https://www.willbutton.com, which is only going to work if I can spell my name right. Let's go over here to our commit. We've changed that. We're going to give it a message here, added redirect to my site. We're going to push that up to the repo. We want to come back over here to our Terraform repository, and we've got a new branch up here, so we want to open up a pull request. So we'll go ahead and create that. We don't need a lot of details because we're just kind of playing around right here. But look at this. We've now got a check that's pending from Terraform Cloud. That's pretty cool, right? Let's go see what it's actually doing. So if we take a look at runs over here, there's actually nothing running. So what Terraform is doing right now is it's creating the Terraform plan to show us what changes would be made if we actually merge this pull request in. Our checks have passed. If we click on show all checks here and go to the details, it takes us over to our Terraform Cloud app and shows us our plan and says that it's going to create a redirect for us just like we wanted to. But notice it says here planned and finished, meaning it just planned it. It hasn't actually made those changes yet. And we can test that, right? We can go to opswad.com or opswad.io /will, and we get a 404 error. So clearly it's not there. Actually, that was the URL, right? Yeah, all right. Make sure I'm showing you good stuff here. So let's go ahead and merge this in. We'll confirm that. We can delete the branch because we no longer need that. And so now, look at this. Our current run just switched over to merge pull request number 1 from the repo. So that's in process. So now we can confirm and apply that, confirm the plan, and that's going to kick off actually doing the work. So we did get a bit of a double plan there. We got the plan when we opened the pull request, and then the plan when we confirmed it and executed it in Terraform. A little bit of duplicated, but it's really nice to see what that Terraform plan is going to do before you merge that pull request. So that's finished. And so if we did everything right, let's make sure our site's up as expected. So yep, that's still working. And now if we go to /will, it kicks me over to my own website. And that's how the pull request workflow goes with Terraform Cloud. Now let's build that same infrastructure, but this time using Pulumi. So if you noticed, whenever we used Terraform, we actually had 2 repositories we were working with. There was the application code repository that you see here on my screen that was our website we deployed. And then we had a second repository that contained our infrastructure code with our Terraform resources. With Pulumi, though, we're going to do everything in the application code repository. So I'm going to start by creating a new directory, and I'm going to call it infra. And then we'll switch over to our tab here, and I'm going to jump into that infra directory I just created. And then run the command Pulumi new JavaScript and give it a name of Next.js blog. And that's going to be the name that it shows up in my Pulumi dashboard as. JavaScript, telling it which language I want this built in. With Pulumi, you can use JavaScript, TypeScript, Golang, C#, and I think Python. So I am going to change the stack name to prod here because we're deploying our production code. And let's take a quick peek here. If we look in that infra folder now, we've actually got an entire Node.js application inside this folder. So that's going to add a little bit of overhead, but not a lot. And I think the overhead that it adds is really worth it. So let's do this. We're going to do an npm install and install the AWS library and our Cloudflare library with the save flag, so that gets written to our package.json. And you don't technically have to install those packages because we're not running Pulumi locally, but when we did, it adds them to our dependencies here in our package.json file, and that's going to give us some really nice autocomplete and documentation features that we'll see come into play here in just a few minutes. So we'll open up our index.js file, which is our main entry point into our Pulumi application. And we're going to add our AWS library. And we'll add our Cloudflare library. And we'll also crank that font up so that you can see what I'm doing here. All right, so the first thing we need to do is create our S3 bucket. We're going to do that declaring a variable called site bucket. And that's a new AWS S3.bucket. And we give that a name. So we're going to call it opswad.io, just the name of our website. And then we need to give it some arguments. And here's why I did the npm install, because we may not know what those arguments are, but I can command click on bucket or control click if you're using Windows. And that takes us right to the type definition for the bucket, which tells us the parameters we have available as arguments. Just makes it kind of nice whenever you're working with a new resource and not sure what you need to add. In this instance, I know what we need to add, and we need to add our site domain as the name, which means we also need to create that variable. So we'll call site domains equal to, it's just going to be a string of opswad.io. And then we're going to configure this bucket as a website. So we'll do that and give it an index document of index.html. We also need our ACL for our bucket. So we'll do const bucket ACL. It's going to be a new AWS.S3 bucket ACL v2. And we'll give that a name of bucket ACL and supply our arguments of bucket, which is going to be our site bucket.id. Again, that's the site bucket that we just created right up here. And our ACL is just a string that's going to be public read. Now we need our site bucket policy. And just to make this a little bit cleaner, we're just going to create a simple function here. And all it's going to do is return a stringified JSON object that's just a regular AWS site bucket policy The only thing we're doing here is substituting our bucket name into the resource as we build that out. So now we need to apply that. So we'll do const bucket policy is a new AWS S3 bucket policy. And the bucket we want to apply it to is our site bucket.bucket. And then the policy is going to be site bucket.bucket.apply, and then give it the name of our function so that it can get the JSON for that. So that's it for our AWS stuff. Let's go create our Cloudflare DNS entries now. First thing we're going to do is create an async function. We're going to call it get CF zone ID, spelling that right, because we need to create these DNS entries in the opswad.io zone in Cloudflare. But in order to do that, we need the ID of that zone. So we're just going to grab that right up front, and then we'll have it available for the rest of our operations. So that's just going to use the Cloudflare API to get that zone and then return the ID for that zone. All right, so now let's configure our root DNS name. To do that, we're going to do a new Cloudflare record. We'll call that our root DNS. It takes arguments. Name is going to be our site domain variable. The zone ID, this is where we're going to call that function that we just created to get the zone ID. Our type is going to be a CNAME. The value is going to be equal to the site bucket we created over in S3, the website endpoint that was created by AWS for that. TTL, we'll just give it 1 for now because we don't really care. And again, proxied is going to be true so that we can take advantage of Cloudflare's DDoS protection, caching, and the page rules that we want to add. So that's for the root DNS name, and then we want to create our www DNS record. That's going to be another Cloudflare record. The name of this one we'll just call www, and this is going to look just pretty much identical to the record that we just created. The main difference here is the value of this DNS record is going to point to our site domain name, which is the record we just created up above. Again, TTL1, because I don't really care about it, but we do want it proxied. Then we'll go ahead and export a couple of variables here. We're going to export one called website URL, which is going to be equal to site bucket .website endpoint. This will be the AWS URL for our website. And then we'll go ahead and export bucket name of site bucket.bucket. And those really aren't absolutely necessary, mainly just including them here so that you can see within Pulumi that you can export variables for your own reference or to use somewhere else in your application. So that should build our Pulumi resources. Now we just need to set Pulumi up to run, and we're going to do that in our deploy.yaml file. Right? This is, if you recall, how we're actually deploying our application. We do the npm install lint, run our build process, and then sync the files that are created to our S3 bucket. But before we do that, we need to provision our infrastructure, right? So we're going to go up here before we start doing our website installation, and we're going to install Pulumi. And we need to tell the GitHub Actions that this Pulumi code lives in our infra folder so that whenever it runs the Pulumi commands, it knows it needs to look in this infra folder, not in the application root. The command is going to be npm install. Then we're going to do a uses to grab the Pulumi actions. We'll give this action step a name, and then we're going to use with the command up. So this is the equivalent of running Pulumi up within a GitHub action. Our stack name, we want to deploy our prod stack. And again, our work directory is infra. And there's a little bit of a difference here. Within our Pulumi up step, it's called work dir, but when we're installing the npm packages, it's called working directory. Just keep an eye out for that. Finally here, we need to set some environment variables. Our Pulumi access token is going to come from secrets, and it's called Pulumi access token. And that is just an environment variable that I set over in my GitHub repository. This is my token from Pulumi that gives me read-write access to my Pulumi account. When I merge that pull request in, let's take a look here. I actually installed the Pulumi bot into my GitHub organization, and that gave me this comment here. So the Pulumi bot recorded a comment on my pull request showing me exactly what it was going to do. And we can go ahead and delete the branch here because we don't need that. Then if we go take a look at our GitHub actions for that merge, we can see that all of the steps completed successfully, including where we installed Pulumi and ran the Pulumi action. So if we take a look at my Pulumi dashboard here, there is a new project, the one that we created called Next.js demo. We've got our prod stack because that's the only one we're tracking. And here's where those exports I created are logged. So they're logged as outputs in my project, the website URL, which is the AWS URL, not our actual DNS entry for opswad.io. And then let's jump over to my S3 console. We can take a look. Here is my bucket. Now, Pulumi does do this. I told it I wanted to deploy it to a bucket named opswad.io. It adds a little bit of a unique string onto the end of it just for their own tracking purposes. That's fine with me. Doesn't really matter. And we pushed our application code up into that folder. And then finally, let's take a look at our Cloudflare DNS. Here are the two resource records we created. We have the www CNAME that points to opswad.io, and then the opswad.io CNAME that points to my Amazon S3 bucket. So the last thing we wanted to do to match the actions we took with our Terraform configuration was to create our Cloudflare page rule. So we're going to do that, create a new variable called page rule. That's going to be a new Cloudflare page rule. We'll give it a name, supply some arguments. So our zone ID, again, is going to be our getCFZoneID function. The target is what page is it going to redirect. We'll do a little bit of string manipulation here. So we're going to do site domain, which will be opswad.io/will. And then we tell it some actions that it needs to take, which is going to be the form of a forwarding URL, and the forwarding URL that redirects with a status code of 302. And then the URL that it redirects to is going to be https://www.willbutton.com. So that's a new change. So we want to do that into a new branch. So we'll create a new branch, call that site redirect. Go ahead and hit create. We'll check that in. Make a little comment here. Redirect to my site, and I spelled that wrong, but it doesn't really matter because it's just for educational purposes. We'll push that up to the repo. So now if I go back over here to my code repository, it shows me that there's some new code there. So we'll open up a pull request. It's really bothering me, so we'll change the spelling there. We'll create that pull request. So check this out. My pull request is still open. I haven't actually closed it yet or merged it yet, but the Pulumi bot that I installed has already made its comment telling me what changes it's going to make to the infrastructure. Those checks were successful, so I get the green check mark here, so I can go ahead and merge it. Merging with administrative privileges because I have this repo set that someone has to review it, but I don't have anyone here to review it. So we'll go ahead and merge that in. We can delete our branch, and now if we go over to our actions, when our actions complete running, we can see that they were all successful here. So based on that, we should be able to go over to Cloudflare here, go down to our page rules, and check that out. We have a page rule for opswad.io/will with a 302 redirect to my website of willbutton.com.
So now the question becomes, which one is better? Which is the point of this whole video. Well, from a technical standpoint, we did the exact same thing with both tools. So can't really determine it based on which one failed and succeeded because they both succeeded. So let's look at some of the other things. I think it really comes down to the code, right? Because when you look at Terraform, it was pretty declarative. It was just kind of straightforward. Here's a resource. Here's what you do with it. And for Pulumi, it was absolutely 100% writing code in JavaScript. And so based on who you're working with, that may influence your decision. Because the way I look at it is I think about who I'm building this application for. Because ultimately, I don't want to be the person maintaining this long term. I'm not trying to build myself a job where I've got to babysit this thing. I want to build it, enable teams, and let them go do their thing as fast as they possibly can. But you got to give them the right tools for that. And I think that for me is why I like Pulumi, because really I want my developers doing their own DevOps. I'm going to put in some guardrails so that they're doing it the way I want it deployed, but I actually want them doing the work. And so that's where it kind of comes into the difference here, because with Terraform, we had the code in a separate repository. Now you can put your Terraform code in the same repository, but the Terraform docs recommend against doing that. And I figure they probably know a little bit more about Terraform than I do, so I'm just going to go with their recommendation. But it's a separate repo, right? So if I want my development teams doing their own DevOps, I've got to go send them off to this other repo. But with Pulumi, I can put the infrastructure in the same repo where they're already writing the application. You saw the Pulumi bot. It gives them the diff right there in their pull request if they've made changes, so they can confirm what they're doing before they deploy it. And this for me is the real winner, the winning statement. It's all done in the language that the developers are already working in, so they don't have to go learn the Terraform syntax for creating a resource. They can write it just using their own application code or the language that they're already using for their application. So just to wrap that all up, you can do it with either one. They both work. As a matter of fact, in a lot of cases, Pulumi is actually using Terraform under the hood. So the big distinction for me is whether you want to do it with a declarative type syntax or use the application code syntax, and that really comes down to who's going to end up maintaining and supporting this in the long run, because you want to give it to them in a format that they already know how to use and consume so that they'll be more successful with it. If you like this video and you want to see more about how all these different parts of DevOps tie together into a DevOps career or building and managing applications at scale, be sure and check out the roadmap guide that I created. I'll have a link for it down below. It's kind of a choose your own adventure guide, so you could actually open it up and take a look at the infrastructure as code section in that guide and then see which other parts of DevOps that integrates with, and go check those out and pick and choose your own education path for learning DevOps skills. Thanks for watching, and I'll see you in the next video.